Hi everyone, welcome to Job Fever. So today we are going to start tutorial of object oriented programming, which is hook concept. So we are going to start from core to advanced. It might take some time to understand, so please be calm and try to understand. So it will take almost 1.5 hours to understand each and every point. So we are going to cover all these point in this tutorial. So this tutorial is for beginners. Okay, so we are going to cover object, class, inheritance, polymorphism, abstraction, and encapsulation. So these all are pillars of object oriented programming. So Java also use object oriented programming concept, oops concept. So we'll see one by one how. So we are going to cover all these topics, so we'll discuss one by one. So we are going to cover class and object. Okay, so in class and object we will cover what is class, object, and syntax of class and object with example, and difference between class and object. And abstraction will cover what is abstraction, syntax, and example, how to achieve abstraction by class and by interface. So with the help of the abstract class and with the help of the interface, we can achieve abstraction. So encapsulation, in encapsulation, we are going to cover what is encapsulation, its syntax and example. Okay, we are going to cover inheritance. Okay, so what is inheritance and its type? What is single, multiple, multi-level, hierarchical, and hybrid inheritance? Syntax and examples of single, multiple, multi-level, hierarchical, and hybrid inheritance. And after that, at last, we'll cover the polymorphism. So, what is polymorphism? Its syntax and example. What is compile time and runtime polymorphism with examples, and difference between compile time and runtime polymorphism. So, we are going to cover all these topics one by one. Okay, so all the pillars of object oriented programming will cover in this topic. So please be calm and try to understand each and every point. So this tutorial is for beginners from core to advanced, so you'll understand every point from core to advanced. So let's get started. Let's learn together. Class and object. Okay, so in Java, classes and objects are basic concepts of object oriented programming. Okay, so if you want to understand oops, then firstly you have to understand the Java, how can you create classes and objects. Okay, inside the Java. So data are used to represent real world concept and entities. Okay. The class represents a group of objects having similar properties and behavior. So the class represents a group of objects, okay, having similar properties and behavior. So class is a group of object, okay, having similar properties and behavior. For example, the animal type dog is a class. Okay, so here dog is a class, while particular dog named Tommy is an object of the dog class. Okay, so here dog will be the class name. Okay, and Tommy will be an object of that class. Okay, so like we can create a multiple instance of class, like we have created one instance of a dog class which is Tommy, so we can also create second another instance of a class. Okay, we can name Seru. Okay, so that will be the another object of that class. Okay, if you want to create the third object of the class, okay, then you can create, okay, maybe any other name. Okay, so any name of dog. Okay, so like this we can create class and object inside Java. So we are going to elaborate what is class and how can we create class in Java. So a class in Java is a set of objects which shares common characteristics, behavior, and common properties attribute. Okay, so Java says a set of object which shares common characteristics. Okay, so it's a set of object, group of objects. It is a user defined blueprint or prototype from which objects are created. So class, that means the it is user defined blueprint of prototype, okay, from which objects are created. So object will be created from class, okay, right? For example, student is a class, so we are going to uh, take another example of student. A student is a class, okay, while a particular student name Ravi is an object, okay. Same like dog example, okay. So here student is a class and particular Ravi, okay, Ravi will be the object of that class, okay. So if you want to create another object of the class, so we can create Saurabh, okay. Saurabh will be one another object of that class, okay. So like this we can do, okay. So second and third, if you want to create, then you can also create that Rakesh will be the object of that class, student class, okay. So like this we can create multiple object of that class, okay. So we can do like this, can create multiple instance of that class, and that instance will be called object. So properties of Java classes. The class is not a real world entity. It is just a template or blueprint or prototype from which objects are created, okay. So it's a template or blueprint or prototype, you can say, from which objects are created. So class is not a real world entity, okay, but it is just a template or blueprint or prototype from which objects are created. Class does not occupy memory, okay. So at the time of declaration of the class, it does not occupy any memory inside Java is a group of variables. Class is a group of variables of different data type and a group of method, data types and group of methods. So for getting the class, you have to declare the variables, we have to declare the method, okay. So it's a group of variables, you can say, and group of variables and group of data type. A class in Java can contains data members, which is field, method, okay, constructor, blocks, nested class, so interface. So class contains all these things, which is field, method, constructor, block, nested class, and interface. So class syntax and example. So how can you create class inside Java? We'll see. So this will be the syntax of class, access modifier, and class name. Okay, like public, class, and class name. Here class name will be dog, and this is the class syntax. The This is the class keyword you have to use to create the class, and here access modifier like public. So this will be the data member, method, constructor, nested class, and interface you can create inside this class. So this is example of class, how can you create class. So here class student, okay. So this is a keyword to create the class, and this is the class name, which is a student. So this is these are the data members, okay. So id is a data member, student id, and name. So you can also call instance variable. And this is the main method we have created inside this class, okay, to create the object of that class. So we're creating a student s is equal to new student. That means that we're creating the one object of class, that may be one instance of a class. So s1 is one instance of class. So creating an object of a student, so we can call s1 instance of a class or object of a class. So for creating this object, we can use this student s1 is equal to new student, like this we can create. So with the help of the new student, it will create the object, and it will initialize into this s1 reference variable, and we can call like s1 dot adn s1 dot name, and we can get the adn value, adn name. So like this you can create class inside Java. So components of Java classes, we'll see one by one. So modifiers, a class can be public or has default access, okay. Class keyword. So class keyword is used to create a class. And before just now we seen this. Okay, so class keyword, we need to create class keyword need to create class inside the Java. Class name, so the class name should begin with an initial letter. Okay, capital letter it should start. So modifier and with class keyword with class name, so we can create the class and super class if any. The name of the class is parent if any, preceded by the keyword extends. A class can only extend subclass. Okay, extend one parent. So in case of the super class child class scenario, okay, so with the help of the extend keyword, you can extend that properties of your parent class or super class inside your child class or subclass. Okay, so parent class called parent class is also known as super class, and child class is also known as subclass. So that concept we can see in inheritance. So interfaces, a comma separated list of interfaces implemented by the class if any, preceded by the keyword implements. A class can implement more than one interface. So a class can implements more than one interface with the help of comma separated. So a class can also extend class, and class can also implement interface. Okay, these are, and how can we surround this class? So with the help of the double curly braces. Okay, so one curly braces two for starting the class, and at the last we have to close the class with the help of this closing curly braces. Okay, so I think we have seen everything uh, inside this. So we have completed this component of Java classes. Now we're going to see object. So we are going to understand object in Java. So let's get started. An object in Java is a basic unit of object-oriented programming and represents real life entities. Objects are the instance of a class. So here objects are the instances of a class that are created to use the attribute and methods of class. Okay, so we create objects to use the attribute and methods of a class. Attribute, that means the data field. Okay, field of that class. A typical Java program creates many objects which, as you know, interact by invoking methods. Okay, an object consists of, so you can create multiple objects of any class. You can create multiple instances of a class. An object consists of a state, okay, behavior. So state, that means that it is represented by attributes of an object. Okay, it also reflects the properties of an object. Behavior, it is represented by a method of an object. It also reflects the response of an object with other object. Identity, it gives a unique name of a object and enables an object to instance object to interact with other object. Okay, state, behavior, and identity. Example of an object, this is dog. So identity of, so this will be the state, that means the breed, age, and color. So state is nothing. State is very all the variables that you are declaring inside the class. So breed, what will be the breed name of that dog, age, and color. Okay, so this will be the state. And what will be the behavior? Behavior of that dog will be bark, sleep, and eat. That means all properties of that class, all properties of dog. So this will be the behavior. And identity, name of the dog. So when at the time of creating the object of class, you provide the name of that class, which is if you're getting the object of dog class, then you are making Tommy as an instance, Tommy as an object. Then Tommy will be identity of that class. Okay, that object. So declaring object. So how can you declare object? We'll see. When an object of a class is created, the class is said to be instantiated. So object of a class is created. The class is said to be all the instances shares the attribute name and behavior of the class, but the values of those attribute, that is states, are unique for each object. Okay, a single class may have any number of instances. We can create the multiple instances of a class. So here class dog is there, state and behavior. Inside the state we have breed, age and color, and inside the behavior we have the bark, sleep and eat. So these will be the all the variables, these, and these all will be the all the methods. So this is the class dog, and these are the instance, that means the object 1, object 2, object 3 and object 4. Okay, so we have created four objects, which is dog 1, dog 2, dog 3 and dog 4 of class dog. Okay, so these all are the states and behaviors of dog class. As we declare variables like type name. Okay, this notifies the compiler that will use the name to refer the data whose type is type. Okay, which a primitive variable. This declaration also reserves the proper amount of memory for the variable. So for reference variable, the type must be strictly a concrete class. In general, we can't create object of an object class or an interface. So you can't create the object of an object class or an interface. So we can create the object of only class. Okay, let me the concrete class. So we are going to create one uh, instance of dog. Okay, so how can we do dog toffee we have created. Okay, so if you declare the reference variable toffee like this, okay, its value will be undetermined null. Okay, so the toffee value will be here null. Okay, until an object is actually created and assigned to it. So how can you create the object? So with the help of that dog toffee, you have declared that class. You have declared the object of that class. That means you are trying to create an object. Okay, so before creating that object, you are declaring that you are declaring variable of that object, or variable of that class. So dog is a class here, so we are creating one variable of this that. Okay, we're trying to create instance. So dog toffee, so here toffee will be the null. Okay, so what we have to do next, what we have to next, simply declaring a reference variable does not create an object. Okay, so we have declared reference variable here. Okay, reference variable of dog you have declared here, but it will not create the object. So how it will create the object? For that purpose you have to use new keyword like dog toffee is equal to new dog. Okay, the new, with the new dog, the object will be created and that object will be assigned to this toffee. Okay, so like this you can create. So here you have to do like dog toffee is equal to, okay, new dog. With the help of new keyword you can do. Okay, so like this you have to do new dog, then it will be the complete creation of object. So you have created the object and you have assigned that object to this dog toffee. So if you declare a reference variable toffee like this, its value will be undetermined, which is null, until an object is actually created and assigned to it. Simply declaring a reference variable does not create an object. Okay, so I think you understood the point. Initializing a object, how can you initialize? So the new operator, just now we discussed the new operator instantiated a class by allocating memory for new object and returning a reference to that memory. So with the help of the new keyword, it creates memory inside the heap memory. Okay, so for all the instances, memory will be created inside heap memory. The new operators also invokes the class constructor. Okay, so how can you create the class and how can we initialize the object? We'll see in this example. Okay, so there is a dog class. Okay, the instance variable is name, breed, age, and color. Here constructor, all the constructor name. Okay, name, breed, age, and colors. So all the variables we are initializing with the help of the constructor. And this is the method: get name, get breed, and get age, and get colors. Okay, so these are the getters method. Okay, to fetch the value and get color, and these are two string, and this is the main method. So inside the main method, what we are doing here, dog top is equal to new dog. Okay, so just now we discussed, okay, in previous slide. So dog toffee equal to new dog. So here we are getting the new dog instance of one dog, which is toffee. Instance of dog, which is toffee, that means the object of one object of dog. So here we are passing toffee, name of the dog, and breed of dog, and age and white color of dog. Okay, so one instance will be created with the name of toffee. Okay, so the memory will be allocated inside the heap memory because we are using new keyword. Okay, so one instance toffee will be created here. Okay, so like this we can declare the object and we can create the object, the new keyword. So output will be, my name is toffee and my breed, age, and color is papillon 5 and white. So output will be like this. Way to create an object of a class. So how can we create, how many ways we can create the object of a class? So we'll see one by one using new keyword. Okay, it is most common and general way to create an object in Java. Okay, so with the help of like if you have a test class, then test t is equal to new test. With the help of the new keyword, you can create the object of a class. Okay, you can create the instance of any class with the help of the new keyword. And second, using class dot for name. With the help of the class dot for name, you can also create. So there is a predefined class in java.lang package with name class. Okay, the for name method returns the class object associated with the class with the given string name. We have to give a fully qualified name for a class on calling a new instance method on this class object. So we have to do class dot for name. Okay, we have package and new instance. Okay, so like this we can create a object of any class. So it will return a new instance of class with the given string name. So this will be the object of test. Okay, and we can create like class dot for name, and consider class test present in com dot p1 dot package. So class test is present in com dot p1 dot. Okay, so we have provided the package and the new instance. So like this we can create the object of a class. So this is the second way to create the object of a class, and we see the next way, which is third. With the help of clone, we can create clone method is present in java.lang object. It creates the and creates and returns a copy of a object. So like this we can do. So previously in first scenario we have created like this, like test t1 is equal to new test. So how can we t1 dot clone if we use, then we'll get clone of one t1 object, so which is t2. So like this we can making copy of t1. Okay, so with the help of the clone method, so like this we can create the object of any class. And we have fourth method, with the help of deserialization we can also create. So deserialization is a technique of reading an object from saved state in the file, referred to serialization and deserialization in Java. So you know the serialization and deserialization. If you don't know, I have already made the video on deserialization and serialization. You can go and you can watch. So at the time of the deserialization, you can make the copy of. Okay, so here we are creating file in file input stream file name. Okay, a new file input stream file. Okay, output input stream and in dot read object. So here we are reading. Okay, with the time of deserialization, we are creating the object of object class. So like this we can create object of any class. Okay, so we have four ways to create the object of any class. So you can use any scenario. So difference between class and object. At last we'll discuss what is difference between class and object. So class is a blueprint of an object. It is used to create object. Okay, and an object is an instance of a class. So class is a blueprint of an object and it is used to create object, and an object is instance of a class. No memory is allocated when the class is declared. So at the time of the class declaration, there will be no memory allocation. So memory allocated as soon as object is created. So once you will create the memory with the help of new keyword, then memory will be created inside the heap memory. A class is a group of similar object. Okay, an object is a real world entity such as book, car, etc. Class is a global entity, and an object is a physical entity. A class can only be declared once. A class can only be declared once. Okay, it should be unique. An object can create many times as per requirement. So you can create multiple objects. An example of class can be a car. So car can be a class, but objects of a class can be BMW, Mercedes, so and Ferrari. It is like so. Like this, we can differentiate class and object. So we are going to understand the abstraction. So these are the pillars of OOPS concept: object, class, inheritance, polymorphism, abstraction, encapsulation. Okay, so now we are going to cover abstraction. So our focus will be on abstraction. So how can we achieve abstraction? We'll see in next slide. Okay, what is abstraction? Firstly, we'll try to understand. So in object-oriented programming, abstraction is one of the four fundamental principles, along with encapsulation, inheritance, and polymorphism. So these all are the pillars of object-oriented programming. Abstraction in OOP is the concept of hiding the complex implementation details and showing only the essential features of an object. So abstraction in the OOPS is the concept of hiding the complex implementation. You don't know the implementation, how it is implementing. You know only the essential things. Okay, so it will be visible only essential things to user. So there is no relation between your code, how you are implementing. Okay, so abstraction is a process of hiding the implementation details and showing only functionality to the user. In simple word, you can say like this: it shows only essential things to the user and hides the internal details. Okay, and for example, sending SMS where you type the text and send the message, you don't know the internal processing about the message delivery. So user don't know how you are sending the message. Okay, if user want to send the message, then user can easily send, but user don't know the internals of how message is being sent. In Java, abstraction is achieved by interfaces and abstract classes. So we can achieve 100% abstraction using interfaces. Okay, 100% abstraction we can achieve with the help of interfaces, and partial we can do with the help of the abstract classes. So we are going to see both. So we'll see one by one. So abstraction by abstract class. So how can we achieve? The abstract keyword is a non-access modifier used for classes and methods. Okay, firstly we have to understand the abstract keyword. So we use abstract keyword with class and method. So if you are using with the help of the class, with class, that means the you are making the abstract class, and for making abstract method you can use abstract keyword with method. Okay, so abstract class is a restricted class that can't be used to create object. So you can't create the object of abstract class. To access it, it must be inherited from another class. Okay, so if you want to create the uh, object of that abstract class, that means that you have to inherit in another class, and then you have to create the object of that class. Okay, That means class A is the object class, and if you want to get the object of class A, then you have to get a class B, and you have to extend that class A to class B, and then you can create the object of class B, and then you can access the methods which is inside class A. Okay, so like this you can do. So abstract method can only be used in an abstract class, and it does not have a body. Okay, so you can create abstract method inside only abstract class. The body is provided by subclass initiated form. Okay, so interface also you can also achieve the abstraction. How? So there is no need to provide any abstract keyword in interface one, or because all the method which is inside interface will be automatically abstract method, so there is no need to provide any abstract keyword in interface. Okay, so but if you want to create the abstract method inside the abstract class, then you have to use abstract keyword. An abstract class can have both abstract and regular methods. So how can you do? Okay, so see, this is the one abstract class, this is the abstract class, and this is the abstract method. So if you want to create the abstract method inside the abstract class, then you have to use this abstract keyword with method. So, and this is the concrete class. Okay, normal class like public void sleep. So like this, if you want to create the object of animal class which is abstract class, so you will get this error. Okay, that means you can't create the object of abstract class. So how can we do? So we have to extend this abstract class, and then you can provide the implementation of abstract method, and then you can create. So like this you can do. So abstraction by abstract class. So we are going to see how can we create, how can we achieve abstraction with the help of the abstract class. So this is abstract class. One animal is a animal class is abstract. So which is defined with the help of the abstract keyword. So abstract method is there. This is the abstract method. Okay. So don't have a body. So abstract method have only implementation. Okay. So sorry, only declaration. So there is no body of abstract method. So we have animal sound abstract method in animal class, and we have regular method which is concrete method sleep. Okay. So how can we achieve? So we have one class which is pig class, and we are extending animal class inside pig class, and we have one abstract method inside animal class. So what we are doing here, we have animal sound, so we are implementing animal sound inside pig class. Okay, the body of animal sound is provided here, so we are providing implementation of abstract method which is animal sound. Okay, inside pig class. So like this we can achieve abstraction with the help of the abstract class. And if you want to call, then we can call like this. We are creating the instance of pig class. Okay, so for creating the object you can create like this, and my pig dot animal sound, so we can call the this method, and after that my pig dot sleep, you can call this sleep method. Okay, so we can call the method which is available inside abstract class. Okay, and which is available inside this inherited class. Okay, so both the way we can do. So better to use interface for achieving the abstraction. Okay, so nobody is using abstract class to achieve the abstraction. So always it will be great to use interface to achieve the abstraction. Industry is also using this. So let's see how can we achieve with the help of the interface abstraction by interfaces. So we have one animal class. Sorry, we have one animal interface, and we have two abstract method. One is animal sound and another is sleep. Okay, so all the method which is inside the interface will be by default abstract method. Okay, so we are not providing any here abstract keyword. Okay, so by default all the method which is inside the animal interface will be abstract method. Okay, so we so interface method does not have a body, does not have a body. That means the abstract method does not have a body. That means the we have to implement body. We have only declaration here, and if you want to declare implement the body, then we have to do inside the inherited class. Okay, like we have inherited class, like we pick class. So here we are implementing animal. So we have two methods. So we are implementing animal sound. Okay, and then we are implementing sleep sleep method inside this pig class. Okay, and after implementing this pig class, what we are doing here, so we are creating an instance of my pig, and we are calling my pig dot animal sound and my pig dot sleep. Okay, so we are calling uh, method of method of animal class. Okay, which is implemented in pig class with the help of pig instance. Okay, my pig dot animal sound and my pig dot sleep method. So like this we can achieve abstraction with the help of the interface. So I think you understood. Understanding of OOPS. So this is the graph, this is the architecture of OOPS concept. So object class inheritance, polymorphism, abstraction and encapsulation, these all are the pillars of OOPS concept. So we are going to concentrate on encapsulation into the lecture. Okay, so our focus will be on encapsulation in pre-advanced. So encapsulation is a fundamental concept in object-oriented programming (OOP) and is widely used in Java. So it is a part of OOPS concept. It is a pillar of OOPS concept. Okay, so it is a concept. So Java also follow OOPS concept. So encapsulation is defined as the wrapping up of data under a single unit. Okay, so we wrap up one data inside a single unit. It is a mechanism that binds together code and the data it manipulates. So it's bind the code and data together. Another way to think about encapsulation is that is a protective shield that prevents the data from being accessed by the code outside the shield. So actually we made the shield for with your data members and variables. Encapsulation involves restricting direct access to some of the object's component, which is way of preventing unauthorized or unintended interferences. Okay, so it restricts your direct access of your data. So it prevent unauthorized access of your data. Okay, so it will be always better to use encapsulation. Okay, if you are doing programming. So how can we do in Java, and how can we achieve encapsulation with the help of the Java code? So we'll see after this slide, and we'll understand and how we make encapsulation in how we achieve encapsulation in Java. We are going to see. So data hiding. So encapsulation allows you to hide the internal state of an object from the outside world. Okay, so you are hiding your internal state from outside of a world. This is typically achieved by making the object field variable. Okay, achieved by making the object field which is variable private. Okay, so in Java, how can we achieve the encapsulation? We can make all the fields which is variables as a private and providing public method to access and update values of these fields. Okay, so we are going to make all the variables private and all the method we are going to make public. Okay, so like this we can achieve. So private, that means the you can't access outside of class. If you are making the private variable, if you want to if you want to use that variable, so you can use with that of only getters method you can fetch the value. Okay, so we'll make all the getters and setters method public for achieving the encapsulation, and all the variables we are going to make private and control access by providing getter and setter method. Same thing just now we have discussed. Okay, so by providing getters and setter method, we can control how the data is accessed and modified. It ensures that the data is accessed in a controlled manner and can prevent invalid data from being assigned. Okay, so just now we have discussed about this getter and setter method, and improves maintainability and flexibility. If you are using encapsulation improves the maintainability of the code because it separates the internal implementation details from the external interface. It also makes it easier to change the internal implementation without affecting other part of code that rely on your public interface. Okay, easier to change the internal implementation without affecting other part of code. Enhanced security. Encapsulation helps in protecting the integrity of data by preventing unauthorized or incorrect modification. This is particularly important in applications where data security and integrity are critical. So we can also achieve security with the help of this encapsulation. So we are going to see encapsulation example. So how can we achieve encapsulation in Java? So private. So we have one class which is person class. Okay. So we have name and age. So what we did here, so we have declared name and age private. Okay, so this is our first concept. So we have made all the variables as private, and if you want to assign, if you want to the value of your fields, then we are assigning with the help of constructor. Okay, name and age. So with the help of the constructor, we can also assign, and we are making all the setters and getters method public. Okay, so if you want to get the fetch the name, so we have get method get name. If you want to uh, get the if you want to fetch the value of age of that person, then you can fetch with the help of the get. So all the getters methods are public here. Okay, and all the setter methods, the setters method which is set name and set age. So the access specifier for set name and set age is also public. So all the methods will be public and all the variables will be private here. Okay, why we are making private variable? Because you can't access directly outside of class. So if you want to access, then you have to make the object of that class, and then you can access. Okay, method to display person details. Okay, so we have declared one method. How can we fetch the, how can we print the age and name? So we have declared here. And how can we call with that of the main method? We will see. So we have created one object of person and access and modify the private fields using public methods. Okay, so here person dot get name. Okay, so with the help of this person dot get age, we can fetch the name and age of that person. Okay, if you want to set, then you can set with the help of the like this set name and set age. Like this you can set the person detail. Okay, if you want to display, you can display like this. Okay, so no need to do like person dot name and person dot age. Okay, to get the value or to set the value, so that will be not the uh, right way to use. Okay, so like this we can achieve encapsulation in Java. That means we are making the all the variables as private and all the methods as public, and we are binding together all the data member and variable to achieve encapsulation. So this is the way. So we are going to start inheritance. So understanding of OOPS. So this is a diagram by which we can understand pillars of OOPS. So object class, inheritance, polymorphism, abstraction, and encapsulation. So these all are pillars of OOPS. So we are going to cover inheritance today. Okay, in today tutorial we are going to cover inheritance. So I have already covered encapsulation, abstraction, and polymorphism. So you can go to my playlist and you can watch. Okay, so let's start it. Inheritance. So what is inheritance? Okay, so inheritance in Java is a fundamental concept of object oriented programming. Okay, it's a concept of OOP. Okay, object oriented programming that allows a new class to inherit properties and behavior method from an existing class. Okay, so it allows inherit properties and properties which is field and methods from the existing class. Methods and field from the existing class. The class being inherited from is called the superclass or parent class. Okay, so if you are inheriting from the class, so that class will be the superclass or parent class, and the class that inherits from it is called the subclass. Superclass concept and the parent superclass or parent class, and the class that inherits from it is called subclass or child class. Okay, so let's going to give one example. Class A is there and class B is there. Okay, so from class A you are going to inherit, okay, in class B. So class A will be the parent class and class B will be the child class. Okay, so this mechanism promote reuse, enhance code readability, and stabilize a natural hierarchical relationship among classes. Okay, the idea behind inheritance in Java is that you can create new classes that are built upon existing classes. When you inherit from an existing class, you can use method and field of the parent class. Moreover, you can add new members and fields in current class also. So you can inherit the features from properties from your parent class, and you can also add your new features, okay, new methods in your child class. So this will be the advantage of inheritance. Inheritance represent is a relationship which is also known as parent child relationship. EJ, has a and EJ, there are relationship. So EJ, so it support EJ relationship. Terms used in inheritance. So we are going to understand the terms which we use in inheritance. So class. So class is a set of object which shares common characteristics, behavior, and common properties. Okay, attributes. Class is not a real word entity. It is just a template or blueprint or prototype from which objects are created. So class. So it's the basic things. So it's a blueprint prototype of object. Okay, so superclass and parent class. So the class those features are inherited is known as superclass. Okay, or a base class or a parent class. So superclass is also known as base class. Okay, and parent class. So don't be confused. All are same name: superclass, parent class, and base class, and subclass and or child class. So okay, so the class that inherits the other class is known as subclass or is derived class, extended class, or child class. So all are same: derived class, extended class, and child class. Okay, so the subclasses can add its own fields and method in addition to the subclass fields and methods. Okay, so subclass can add on fields and methods. Okay, so it can also inherit from the parent class, and it can also add on class, on fields, and on methods. Okay, inside the child class, inside the subclass. Reusability. So inheritance supports the concept of reusability. That is, when you want to create a new class and there is already a class that includes some of the code that you want, we can derive our new class from the existing class. By doing this, we are using the fields and methods of the existing class. So already if some properties are available in the super class, so if you want to extend the property, if you want to use same properties in our class, then we can do that of the inheritance. Okay, so it support reusability. Okay, so these are the common terms we use in inheritance: class, superclass, subclass, and reusability. So we are going to how to use inheritance in Java. So how can we achieve inheritance in Java? The extend keyword is used for inheritance in Java. So this is the keyword extend, so by which we can extend the superclass, okay, inside our child class. So using the extend keyword indicates you are derived from a existing class. In other words, extends refer to increase functionality. Okay, extend, that means you are going to increase your functionality of class. So you can say like this syntax: how can you do inheritance in Java? So this is one derived class. This is a class. So we are extending the class properties with that of this extend keyword. So this will be the keyword. Okay, so by which we can achieve we can achieve inheritance. So method in here we can declare your own methods and fields. Okay, so this will be the syntax of inheritance. So inheritance example: so how can we make a inheritance class? How can we achieve inheritance with in Java? So this is the example. So I have created one class. Okay, super class. Okay, this is a super class, this is a subclass. Okay, so super class, you can say parent class, you can also say parent class. Okay, and this is the subclass, you can also say the child class. So this will be the super class, this will be the child class, and this will be the main class. Main class to running this method, to executing this method. Okay, so in this class, the animal class, we have one method it. Okay, so animal has property it. Okay, so we have declared one it method. Okay, and we are going to create one dog method, dog class. Okay, so so which is going to extend animal. Okay, so dog can also bark and dog can also eat. Okay, so we are going to extend the functionality of animal. Okay, so now dog class will have two methods, two properties, which is one will be the eat and another will be the bark. Okay, so this will be the common functional common for properties for animal. Okay, so how can we extend the animal properties in dog with the help of the extend keyword in Java? Okay, so class dog extends animal class. So now dog class will have both the method, both the properties, bark and eat, so we can access both. So let's run and check how. Let's see how the result will be. So getting the instance of dog class, dog is called new dog, and dog dot eat, so we'll get the inherited method from animal class. So dog dot it is not, it method is not present in dog class, but we are getting from animal class because we have using the extend keyword here. Okay, so because of this extend keyword, because of inheritance properties, we are getting the it method from animal class, and here inherited method from the animal class, and this animals its food will be printed here. Okay, this will be the output. And method of dog class, so my dog dot bark I'm going to call. So this method is available in dog class, so this method will be called from this dog class. So the output will be the dog barks. Okay, so first this will execute and then after this will execute. So our output will be like this. Okay, so we are going to see inheritance type. So single inheritance, multi-level inheritance, and hierarchical inheritance, and multiple inheritance. hybrid inheritance. So these all are types of inheritance. So we'll see one by one. We'll try to understand from core to advanced. So on the basis of class, there can be three types of inheritance in Java: single, multi-level, and hierarchical. So these all inheritance are supported by Java. Okay, but Java does not support these inheritances. Okay, so we are going to see this and why Java does not support. We are also going to talk. So in Java programming, multiple and hybrid inheritance is supported through interface only. We will learn about interfaces later. Okay, so this we can achieve multiple inheritance and hybrid inheritance with the help of the interface. We can't achieve with the help of the class. Okay, so this will be achieved by the interfaces, and this all we can achieve with the help of the class. Okay, we can also achieve with the help of the interfaces, single, multi-level, and hierarchical. But with the help of the interface and the help of the class, we can achieve in Java. Okay, so other languages like PHP, other languages supports also multiple inheritance. Okay, and hybrid inheritance. But or .NET, I think C++ also supports this multiple inheritance. Okay, but Java does not support multiple inheritance. Okay, so if you want to use, then you can use with the help of inheritance interface. Then it will be applicable in also Java. You can also that means that you can do the same scenario with the help of the interfaces. So let's start it. So we are going to see single inheritance first. So in single inheritance, a subclass is a derived from only one superclass. Okay, so only one superclass will be there, and one subclass will be derived from that superclass. It inherits from only one superclass. It inherits the properties and behavior of single parent class. Okay, and it is also known as simple inheritance. So single inheritance is also called simple inheritance. In below figure, A is a parent class and A is a parent class and B is a child class. Okay, the class B inherits all the properties of class A. So this is the figure here. So here class A is a parent class. So this will be the parent class and class B will be the child class. So class B inherits the properties of class A. So this is example of single inheritance. So how can you achieve single inheritance in Java? So like this we can do. So we have class animal. There is one method in animal class which is it. Okay, and dog. So this will be the parent class and this will be the child class. Okay, so dog extend animals and there is a method inside dog which is bark. So and we can call like this d dot bark and d dot it. Okay, so like this we can achieve single inheritance in Java. So let's so our output will be barking and eating like this. So this is the output. So let's move to new topic, next topic, which is multi-level inheritance. So in multi-level inheritance, a derived class will be inheriting a base class. So derived class is inheriting the base class, as well as the derived class also act as a base class. Okay, so so a derived class will be inheriting a base class. So derived class will inherit the base class, and as well as derived class also act as a base class. So derived class will be also act as a base class for other classes. Okay, in so we are going to see the image how it will work. So this is the base class. Okay, and this is the derived class. Okay, so here class B extend class A, and what is happening here? So class C extend class B. Okay, so this is the multi-level inheritance. So here in below image, class A serves as a base class of a derived class B. So class A is a base class for class B. Class A is a base class for class B. Okay, so this will be the base this will be the base class and this will be the derived class. Okay, and and class A serves as a base class for the derived class B, which is turned as a base class for the derived class C. So now class B will be the base class for derived class C. Okay. So class A. So we'll see the example. How can we do? So here, what we are doing here, animal, there is animal class, so dog extend animal class, okay, and there is a baby dog, so baby dog extend dog class, okay. So animal, dog extend animal class, or baby dog extend dog class, okay. So same like this. So class B extend class A, and class C extend class B, okay. So this is the example of multi-level graph, multi-level inheritance, and this will be the example of multi-level inheritance. So like this we can achieve multi-level inheritance in Java, okay. So here we are calling d dot weep, d dot back, d dot eat. So this will call weeping, then barking, and then eating, okay. Weeping, barking, and eating, okay. So if you are calling d dot weep, so d dot weep will be called from baby dog, and d dot bark. So bark is not available in this baby dog. So this will be fetched from this dog class, because we have extending the class, mm, class dog, okay, in baby dog, okay. So so this bark method will be called from the dog class, and then we are calling here d dot it. So d dot it is also not available in baby dog and dog, so this will be called from animal class, okay. So output will be like this: weeping, barking, and eating. So next, hierarchical inheritance we are going to see. So in hierarchical inheritance, one class serves as a superclass or more than one subclass. Okay, so one class serves as a superclass or more than one subclass. So subclass will be the more here, okay, and superclass will be one. So let's see the graph. So here, image. So here class A is the base class, and these are the derived class. Okay, class B is the derived class, class C is the derived class, and class D is the derived class, and class A is the base class. So class B extend class A, class C extend class A, and class D extend class A, okay. So this is the example of hierarchical inheritance. So this is the example. So animal class, animal eating, so dog extend animal class, cat extend animal class, and okay. So this will be the example of hierarchical inheritance. There is only one base class, which is animal class, and two derived class, which is dog class and cat class, okay. So this the same like here, okay. So only one base class, and we have derived class B, derived class C, and derived class D, okay. So we are calling uh, c dot mu and c dot it from cat class, okay. So our output will be like mu and eating. So this is the example overall explanation of hierarchical interface, hierarchical inheritance. Sorry. So multiple inheritance we are going to see. So in multiple inheritance, one class can have more than one super class and inherits features from all parent class. So here more than one super class will be there, okay, and inherits features from all parent class. So and the inherits class will inherit the features from more than one parent class, more than one super class. So please note that Java does not support multiple inheritance with classes. In Java we can achieve multiple inheritance only through interface. So Java does not support multiple inheritance by classes, okay. So we can achieve with the help of the inheritance in Java, okay. With the help of the interface we can achieve multiple inheritance with the help of the interfaces in Java, okay. So this is the class. So this is the class A and class B. So both are the base class. Class A is also base class, class B is also base class. So we are extending features of class A and class B in C, okay. So this will be the graph of image of multiple inheritance. So but Java does not support by class, so Java support by interface. Okay, so we are trying to achieve with the help of the class. So class A is the class B is there. So message method inside the class A, message method inside class B. So we are trying to extend here. Suppose if we have, but we can't see what we are trying to do. We have class A and we are extending A or B. Both we are extending. Okay, inside class A. So what we'll get? So we'll get here. We'll get compile time error. So it is not possible in Java with the help of the class. Okay, so this concept we can't implement in Java. Okay, so suppose if it were okay, but it is not possible. If we try to do it, we will get the compile time error. Okay, so how can we achieve like this? So we can do with the help of the interfaces. So like this we can do. So we have interface one. Okay, so there is one method which is print A. Okay, and we have interface two, interface two. Then we have method print B. Okay, so we are extending one and two inside this. Okay, inside this the interface. Okay, interface three is there, and we are extending one and two inside this, and we have another one method inside this abstract method inside this interface, which is print A. Okay, so same thing is there. This is the base interface, this will be the base interface, and this will be the extended, okay, interface. So we can achieve multiple inheritance like this with the help of the interface in Java. Okay, so what we are doing here, we have class child implementing 3. Okay, and we are doing the here we are providing the implementation logic. Okay, we are providing the we are overriding, and we are providing the body of this method. Okay, implementation of this method in print A, and we are calling from a child class c dot print A. Okay, so like this we can achieve multiple inheritance by Java. So in previous case it does not work because uh, there's ambiguity. Okay, so it was confused, that means the from which class the method same method will be called. Okay, so that problem we can solve with the help of the default method. So that problem is called diamond problem. Okay, so I have already discussed this diamond problem on this with the help of the default method. How can you solve in video if you go to the playlist, you'll see. Okay, so you will get the Java interview question. So there you will get how can you solve diamond problem with the help of the default method. Okay, so like this we can achieve multiple inheritance with the help of the interfaces. Okay, next hybrid interface inheritance. So fifth will be hybrid inheritance. So it is a mix of two or more of above types of inheritances. Okay, so it is a mix of single or a hierarchical, single or multiple. Okay, inheritance. Since Java does not support multiple inheritance with classes, hybrid inheritance involving multiple inheritance is also not possible with classes. So hybrid inheritance is also not possible with the help of the classes. Okay, so we can achieve inheritance only through interfaces. So same like so this point will be fifth because we have already discussed four. Okay, so same like the multiple inheritance. So Java does not support hybrid inheritance. Okay, so if you want to use this concept in Java, we can do with the help of interfaces. Okay, if you want to involve multiple inheritance to implement hybrid interface, if you want to involve multiple inheritance to implement hybrid inheritance. Okay, so this is the graph of hybrid inheritance. So this is the base class class A, and this is the derived class C, and class B is the derived class. So class C is extending class A, and class B is extending class B. Okay, and class D will be the derived class for this class C. Okay, so class, okay, and class D will be the derived class for class B. Okay, this is the example of hybrid. So class A implements class B extend class A, and class C extends class A. So this will be the example of hierarchical. Okay, so this is the hierarchical. Okay, in hierarchical, uh, okay, so one base class will be extended by two subclass. Okay, so this will be the example of, and if you see this scenario, so this will be the example of multiple inheritance. Okay, this will be the example of multiple inheritance. This from B, C, and D. So what is it is happening here? So we have two base classes, and we are extending two base classes inside one subclasses, inside one derived classes. So class B will be the base classes, and class C will be the base classes. So we are extending both the base classes inside this derived class. Okay, so this is the mixture of hierarchical inheritance and multiple inheritance. Okay, so this is the hybrid. So we can achieve hybrid interface with one or two or more than uh, two or more than two inheritances, like it may combination of single plus hierarchical plus multiple plus single. Okay, so like this we can achieve hybrid inheritance inside polymorphism. So actually, poly means many and morphs means forms. Okay, so the word poly means many and morphs means forms. It's so it's means many forms. So that means you can say that means the polymorphism, one object multiple work, or one object multiple form, one object multiple instance, like this we can say. So this will be the polymorphism. Polymorphism is considered one of the important feature of the object oriented programming. Polymorphism allows us to perform a single action in different way. Okay, so in other words, polymorphism allow you to define one interface and have multiple implementation. So in case of Java, this will be the in case of the Java or any other language, so this will be the description of polymorphism. Okay, so let's so types of polymorphism. This will be the next topic. So method overloading is also called compile time polymorphism. So we have two types of the polymorphism. One is compile time. Second will be the runtime polymorphism. Okay, so compile time polymorphism, there is a other name which is method overloading. Okay, so it is also known as static polymorphism. So don't get confused, because all are the same, looking like same. So interviewer may ask what is the runtime polymorphism, what is compile time polymorphism, and what is method overloading, and what is method overriding. So all are the same name. So method, if compile time polymorphism, then method overloading will be the same name. Okay, and you can also say the static polymorphism. So firstly, try to understand the name of all the polymorphism. Okay, and this type of polymorphism is achieved by function overloading or operator overloading. Okay, so with the both the way we can achieve, first function overloading and second will be operator overloading. Okay, achieved by having multiple method in the same class with the same name but different parameters. Okay, so method name will be same but different parameter will be different. So you can provide one method parameter, two method parameter, three method parameter with have the same data type or a different data type. Okay, so you can consider all of them. The method to be executed is determined at compile time. Okay, so all the method will be executed at the time of the compilation only, compile time. Okay, let's take the example of run compile time polymorphism, which is method overloading. So this is one class method operations. Okay, math operations. We have one method which is add, and with two parameters, a int a and int b. So we are adding here a plus b. Okay, in the same class we have same method. That means we have add method but different parameters. Now we have three parameters: int a, int b, and int c. The type of all parameters are same, which is int. But if you compare with upper add method, so we have two parameters but two parameters, okay, but down we have three parameters, but types of parameters are same int. So we can change here string also. If you need a string, you can take one int, we can take another string, okay. So you can take different type of the parameters or same type of the parameters, so depend upon your use. According to our requirement we can use. Mm, okay, so this will be the example of method overloading, okay, method overloading or compile time polymorphism or static polymorphism. So I think you understood. So let's move for the next topic, which is runtime polymorphism. We also call overriding. Okay, so it is also known as dynamic polymorphism and achieved when a subclass provides a specific implementation for a method that is already defined in its superclass. So method is already defined in superclass, and you are trying to implement in child class. Okay, so you are providing implementation in child class. The method is executed is determined at runtime. So this method is executed at the runtime. So we call runtime polymorphism. So let's see the example of runtime polymorphism, which is a method overriding. So we have one class, animal class. We have sound method. Okay, this is the parent class. Animal is a parent class, and we have sound method, which is implementation of your parent class. Okay, parent class. And what we did in, we have dog class and we have cat class. So what we are doing in dog class, so we are extending animal. Okay, so this will be the dog will be the first implementation class of animal. Okay, so animal is parent class and dog is our child class. So we have first child class, which is dog class. So we have sound method, we have implemented sound method in child class also. So we are overriding the sound sound method, which sound method which is in super class, okay, or parent class. So we are overriding here, we are overridden here. So sound class we have overridden in dog class, okay. So in the same scenario, when you are going to create the cat class, so we are extending the animal, because we this is the properties of the animal sound. So animal can bark, animal can roar, okay. So in cat we are also going to make a so dog, in dog class we have written dog barks, okay, and sound class we written cat mew. So we are extending the animal class in child class, and we are providing the im- implementation of the sound class. That means we are overriding the feature of sound, which is already implemented in animal class. So we have two implementation, we have two child class. First will be the dog and second will be the cat class, okay. So dog can bark and cat can meow, okay. So now we have test class. There we are going to achieve the runtime polymorphism with the help of we created the animal class instance, okay, animal class reference variable and my so we are what we are doing here, we created the instance of new dog class, okay, and initializing in animal class, creating the child class, creating the child class instance and initializing into parent class object, okay. So we are calling the my animal dot sound, and what we are doing down, we are creating the child class, which is cat class object, and initializing in parent class instance variable, okay, which is my animal. So we are calling here my animal dot sound, and we are calling my animal dot sound, okay. So in first case, if you're calling my animal dot sound, so we'll get the dog. What will be the output? So we'll get the sound dog barks. Creating the child class object and initializing it into parent class instance variable, and calling the method of child class with the help of the parent class reference variable is called method overriding, okay. So this will be this process will be called method overriding. So we are achieving method overriding with the help of this. Okay, and then second part we are also achieving method overriding with the help of the this scenario. So here we are also creating the instance object of the child class, which is cat class, and initializing into instance of parent class, which is my animal. Okay, and we are calling the my animal dot sound. So here what will be the output? So what output will be the cat meow. So calling the implementation of the cat class. So like this we can achieve the runtime polymorphism or method overriding. So I hope you understood. If you have any doubt, you can comment and we can discuss on open platform. And I think you liked my effort. So if you're loving, so please like, subscribe, and share. And thanks for watching. Bye everyone.